Friends, in this video, we will be discussing few of the important questions of exercise 3.2 of the NCERT book. We first of all deal with question number 3, second part, compute the product. This is the column matrix given to us 1, 2, 3 and a row matrix 2, 3, 4. First of all, we know that while evaluating the product, we first of all see the order of the two of the matrices. This is of order 3 cross 1 and this is of order 1 cross 3. So when we are finding out the product of these two matrices, if you are finding out the product, then obviously the resultant matrix is of order 3 cross 3. And how do we multiply? We multiply, if we want to find the first element, that is A11, we take the first row and the first column. So 1 cross 2, then 1 cross 3, and then to obtain the third element of the first row, we have 1 cross 4. Similarly, we have 2 cross 2, then you have 2 cross 3, then you have 2 cross 4. Similarly, to obtain the third row, we take the third row, then first, and then second, and then the third element. So 3 cross 2, this is 3 cross 3, and this is 3 cross 4. So what we get is 2, 3, 4, 4, 6, 8, 6, 9, and 12. One of the mistakes what the students do in the paper is that they do not pay attention to the order and sometimes they write it as a 1 cross 1 matrix. So we have to be careful in finding out the product in these type of matrices. Now we move on to question number 6. It says simplify. You have to simplify this thing. So this is cos theta. The matrix is cos theta, sin theta, minus sin theta, cos theta, plus sin theta, and then you have sin theta minus cos theta, and then you have sin theta. So when we are solving it, so what we do is, when we try to solve this one, we start with this expression what is given in the question. Just take it as a scalar quantity. We multiply each element of the matrix by cos theta. What we get is cos square theta. We have cos theta, sin theta, minus sin theta, cos theta, and then cos square theta. Similarly, now we multiply by sin theta. Each element over here, this will give you sin square theta minus sin theta, cos theta. So this is cos theta, sin theta, and this is sin square theta. Now if you add the elements, the corresponding elements have to be added. So this will give you cos square theta plus sin square theta. This is cos theta sin theta minus sin theta cos theta. Again you have minus sin theta cos theta plus cos theta sin theta, and then you have cos square theta plus sin square theta. And you can clearly see this will cancel out this one, cancels out. Cos square theta plus sin square theta is the identity is 1 basically. So again what we get is the identity matrix. So what we get 1 0 0 1. So we get the identity matrix as the simplified matrix for the expression given in the question. Now we move on to question number 13. Question number 13 says, if fx is equal to cos x minus sin x, 0, this is 0, this is 1, this is 0, this is 0, sin x and cos x, then we have to show that fx into fy is f of x plus y. So this has to be shown. So we start the solution. Fx is already given in the question. So what we do is we write fy. Fy is basically obtained by simply replacing the variable x by y, and what we have is cos y minus sin y 0, sin y cos y 0, 1, 0 and 0. Now what we do is we take the product fxn into this fy. So what we have, cos x minus sin x 0, 0, 1, 0, 0. This is sin x and this is cos x. Now we write f of y, that is cos y minus sin y 0, 0, 1. This is 0, this is 0. This is sin y and this is cos of y. Now we multiply both of them. So when we are multiplying, obviously we take the first row for the first row of the resultant matrix, and then correspondingly we just move on from the first column to the second and then to the third. The product will be cos x into cos y, cos x into cos y, minus sin x into minus sin y, minus sin x, minus sin y, this is, and then 0 into 0 is 0. Cos x into minus sin y is minus cos x sin y, and then this is minus sin x cos y. So cos x into 0 is 0, minus sin x into 0 is 0, and 0 into 1 is 0. If you add these three, again you get 0 over here. Now we move on to the second row, sin x cos y, then cos x sin y, you have minus sin x sin y, then cos x cos y, and what we do is now sin x into 0 is 0, again 0, and then again we have 0 over here. Now 0 multiplied by this and this will be 0. Again we get 0 over here, and this will give you 1 over here. If we use the formula what we have learned, cos x cos y minus sin x sin y will give you cos of x plus y. We take out minus common. Sin x cos y plus cos x sin y will give you sin of x plus y 0. Now sin x cos y plus cos x sin y is sin of x plus y. Take out this cos of x cos y minus sin x sin y is cos of x plus y. And if you see and compare this with the question where fx is given, so in place of x plus x, if you substitute x plus y, this is what you will be getting, and so this will be f of x plus y. And hence we are able to prove that fx into fy is nothing else but f of x plus y. Now we just move on to question number 15. Find a square minus 5a plus 6i if a is equal to 201, 213, 1 minus 1, 0. So what we do is, we first of all find a square, we find 5a, we find 6i, and then we substitute those values in this expression to obtain the value. A square is nothing else but a into a. So we have 2, 0, 1, 2, 1, 3, 1 minus 1, 0. And then you have multiplied by 2, 0, 1, 2, 1, 3, 1 minus 1, 0. So this is what you will be getting. And if you take the product, you have 2 cross 2 is 4. Plus 0 plus 1. Then 2 into 0 is 0, 0 into 1 is 0, and 1 into minus 1 is minus 1. Then you have 2 into 1 is 2, 0, and then 0. So 2 plus 0 plus 0. This is 2 into 2 is 4, 1 into 2 is 2, plus 3, this is 0, 1 into 1 is 1, 3 into minus 1 is minus 3, then you have 2, then you have 1 into 3 is 3, and 3 into 0 is 0. So 1 into 2 is 2, minus 1 into 2 is minus 2, 0 minus 1, and 0 into this is again 0. 1 into 1 is 1, is minus 3. So what we obtain over here is, so a square is nothing else but 4 plus 1, 5. Then you have minus 1. Then you have 2. This is 9. Minus 2. 5. 0. Minus 1. And minus 2. Now we just substitute the values. So we have got a square already. Now we can have 5 of a. 5 of a means we are multiplying each element by 5. So 10, 0, 5, 10, 5. 15, 5, minus 5 and 0. Similarly, 6i is clear to all of you. So we start with that expression a square minus 5a plus 6i. We know the value of a square. 5 minus 1, 2. 9 minus 2, 5. 0 minus 1 minus 2. So this is a square. Minus 5a is 10. 0, 5, 10, 5, 15, 5, minus 5, 0, and then you have plus 6i. So the identity element is now being multiplied by 6. So we are multiplying the 6 to each of the element. So this is what we are getting. Now we simply just solve. 5 minus 10 is minus 5 plus 6 is 1. Minus 1, rest of the elements are 0. 2 minus 5 is minus 3. So we get minus 3 over here. Now 9 minus 10 is minus 1. Minus 2 minus 5 is minus 7. Plus 6 is minus 1. 5 minus 15 is minus 10. So you have minus 10. 0 minus 5 is minus 5. Minus 1 plus 5 is 4. And then you have minus 2 plus 6 is 4. So this is what you will be getting as the simplified thing for this expression. This is what the value of the expression is. This is the matrix which represents this expression over here. Now just move on to the next question. Question number 16. Question number 16 says, if A is equal to 1, 0, 2, 0, 2, 1 and 2, 0, 3, then we have to prove that a cube minus 6a square plus 7a plus 2y is equal to the 0 matrix. So if you are solving it, we first of all find a square, that is 1, 0, 2, 0, 2, 1, 2, 0, 3 multiplied by itself. This is 1, 0, 2, 0, 2, 1, 2, 0, 3. This is a square, we remember, is a into a. So we are multiplying both the matrices. On multiplying these two, we get, we will be doing it quickly now. 1 plus 4 is 5. Then 0, 0 and 0. This is 1 into 2 is 2. 0 and 6 is 8. 0, 0 and then 2. Now 0, 4. This is 0, 2 and 3 is 5, 2 and then 3 to the 6. 2 1s are 2, 0 and 6 is 8. 0, 0 and 0. 4 and 9 is 13 and this is 0. So this is what we are getting, a square. Now we find a cube. A cube is a square multiplied by a. So that is 5, 2, 8, 0, 4, 0, 8, 5, 13 multiplied by a. A is 1, 0, 2, 0, 2, 1 and 2, 0, 3. So if you multiply, again we do it at a pace. 5, 0 and 16 is 21, 0, 0 and 0 is 0, 5 is a 10, 0 and 8 is a 24. This will give you 34. Similarly, 2 and 10 is 12, 0, this is 8, and again 0, 4 and 4, 8, and 15 is 23. Now you have 8 was the 8, 0 and 26. This will give you 34. Then 0, 0 and 0. 8 to the 16 and 13 is a 39. 39 plus 16 is 55. So we have obtained the values of a square and a cube. So what we do is we substitute these values of a square and a cube in the given expression to prove the result. So for a while you just keep it on the board. So we start from LHS. LHS is a cube minus 6a square plus 7a plus 2y. A cube is 21, 0, 34, 12, 8, 23, 34, 0, 55. Minus 6 times of a square, it is 5, 0, 8, 2, 4, 5, 8, 0, 13, plus 7 times of a. We are multiplying this matrix by 7. We will be multiplying each element by 7. So what we get is 7, 0, 14, 0, 14, 7, 14, 0, 21, plus the identity matrix being multiplied by 2. So the diagonal elements being multiplied by 2. We now simply have to solve the corresponding elements. You just have to solve it. So what we get is 21 minus 6 5 is 30 plus 7 plus 2. Okay. Similarly, 0, 0, 0 and 0 will give us 0. This is 34. 8 is a 48. Plus 14. You have 12 minus 12. Rest of the elements are 0. You have 8. 24 plus 14 plus 2, and then 23 plus 7, 30 minus 30 is 0. 34 minus 48 plus 14 is 0. 0, 0, 0 and 0. Last is 55 minus 78 plus 21 plus 2 is 23. On solving the whole thing, what we get, all the elements will come out to be 0 and the result will come out to be a 0 matrix. Okay, now we just move on to question number 18. If A is equal to 0 minus tan alpha by 2, tan alpha by 2, 0, and I is an identity matrix of order 2 cross 2, then we have to show that I plus A is equal to I minus A into cos alpha minus sin alpha, cos alpha. So what we do, we start with the LHS. LHS is I plus A, that is 1, 0, 0, 1, and then we add. This will give you 0 minus tan alpha by 2. So tan alpha by 2 and 0. So this will give you 1 minus tan alpha by 2. This is tan alpha by 2 and this is 0. So this is what we are getting this will be 1. So this is what we will be getting as the left hand side. Now if we start with the right hand side, the right hand side involves two of the things. We have to find I minus A and how to convert this thing into tan alpha by 2. So we use the half angle formula. Cos alpha is actually 1 minus tan square alpha by 2. Remember these formulae. Cos alpha is 1 minus tan square alpha by 2 upon 1 plus tan square alpha by 2, and sin alpha is 2 tan alpha by 2 upon 1 plus tan square alpha by 2. Please kindly note these two formulae and learn them properly because they will be used. Okay, so these are the two formulae. So we start with RHS. RHS is I minus A into cos alpha minus sin alpha, and then you have cos of alpha. I minus alpha means we are having 1, 0, 0, 1 minus 0 minus tan alpha by 2, tan alpha by 2, and this is 0. Now what we will be doing, solve this expression, we will be using these two formulas. So please do kindly note them. We just now substitute the values. Cos alpha is 1 minus tan square alpha by 2 upon 1 plus tan square alpha by 2. This is 2 tan alpha by 2 upon 1 plus tan square alpha by 2 with a negative sign. This is 2 tan alpha by 2 upon 1 plus tan square alpha by 2, and then we again write the formula for cos alpha, 1 minus tan square alpha by 2 upon 1 plus tan square alpha by 2. So this will give you 1 tan alpha by 2 minus tan alpha by 2, 1, and then we are finding the product with 1 minus tan square alpha by 2, 1 plus tan square alpha by 2 minus 2 tan alpha by 2 upon 1 plus tan square alpha by 2. You have then 2 tan alpha by 2 upon 1 plus and then you have 1 minus tan square alpha by 2 upon 1 plus tan square alpha by 2. So we just have to now multiply these two, and then we will get the results what we require. So if you simplify, this is 1 into this and then multiplied by this. So 1 minus tan square alpha by 2. The denominator will come out to be same. So already the LCM will be taken. So this is 2 tan square alpha by 2 upon 1 plus tan square alpha by 2. This is 1 into this and then this into this. So minus 2 tan alpha by 2 plus tan alpha by 2 minus tan cube alpha by 2. So what we get next is this multiplied by this. We get minus tan alpha by 2 plus tan cube alpha by 2 plus 2 tan alpha by 2 whole divided by 1 plus tan square alpha by 2 1 plus tan square alpha by 2, and this is now this into this is 2 tan square alpha by 2, and this is plus 1 minus tan square alpha by 2 upon 1 plus tan square alpha by 2. So what we get is, this is 1 plus tan square alpha by 2. This is minus tan alpha by 2 is taken out as common. 1 plus tan square alpha by 2 upon this is 1 plus tan square alpha by 2 1 plus tan square alpha by 2. Now again this is this and this will give you tan alpha by 2. Tan alpha by 2 is taken as common. This is 1 plus tan square alpha by 2 1 plus tan square alpha by 2. This will give you 1 plus tan square alpha by 2 whole divided by 1 plus tan square alpha by 2. We take the brackets. Now this will give you 1. This will get cancelled out. So we have minus tan alpha by 2. This is tan alpha by 2. And this is 1. So what we get is the expression what we are getting here and we got for the left hand side, they are coming out to be equal, and so the equality is being proved. Now we move on to the question number 19. What it gives you that you have to invest rupees 30,000 in two types of bonds, where the first bond say gives you 5% dividend and the 7 interest, and the second one gives you 7% interest. Now two of the situations are given, how much has to be invested, so that we get the interest as rupees 1800, and in the second part we need the interest to be 2000. So what we do is, in the first case we take it to be x, and then this comes out to be 30,000 minus x, and on solving this one, we must have 1800. So 5% of x plus 7% of this should be equal to 1800. In the second scenario, we have 30,000. Again, we take the two of the investments to be y and 30,000 minus y. On this one we are getting 7%, on this one we are getting 7%. In totality we must have 2000. So if you try to express this thing in terms of matrices, we know the elements have to be arranged in such a manner that x should be multiplied by 5% and 5% could be written as 5 by 100 also. So that has to be taken care of. Similarly 7% as 7 by 100. So we have x, and you have to pay attention, we need 5 by 100 here. Now if you write 30,000 minus x, this is 7 by 100. And this will give you 1800. But now, if you want to solve both the parts simultaneously, so what you can do is you can form a 2 cross 2 matrix. And you can write it like this, and over here, this will become 2000. On solving these two, first of all we multiply these two. So when you multiply, what we get is 5x, 100 is there, so 5x plus minus 7x, and then this is 5 plus 21 minus 7 by divided by 100. In the first case we get 1800, then we get 2000. On simplifying, what we get is 2,10,000 minus 2x divided by 100. Again 2,10,000 minus 2y divided by 100, and the equality is 1800. Okay. Now we equate this thing to this one and we equate this to this. On simplification, we get x to be 15,000 and then the value of y will come out to be 5,000. So what it means is that the investments will come out to be 15,000 and 15,000, and over here the investments will be 5,000 and 25,000. Okay, so this is what we will be getting. Now we just move on to the last two questions, 21 and 22. What they give you is basically the order of the matrices, and it simply says that the order of the matrices are given to be X, Y, Z, W, P. The order of the matrix X is 2 cross N, 3 cross K, you have 2 cross P, you have N cross 3, and you have P cross Q. Now, in the question number 21, basically the restrictions which could be there for the expression Py plus Wy to be defined, that is what has to be found. So what we do is, so we have the expression Py plus Wy equal to, we write this as P plus W, why we use the distributive property. So what it means that the order of P and order of W must be equal. So the P is actually, this is P cross K, and W is n cross 3. So the restriction which comes out is that n should be equal to p and k must be equal to 3. So this is the restriction what is coming out. So the resultant matrix will obviously be of the order p cross 3 or n cross 3, and y is of the order 3 cross k. So obviously the multiplication is defined, and this is the condition, and this is the option A. Okay. Now we move on to the second part, that's question number 22nd, the last one. So we just have to, you just have to tell the order of 5x minus 5z with the condition that n is equal to p. The order of x is 2 cross n. The order of z is given to be 2 cross p. So obviously n and p are given to be equal. So the order will either be equal to 2 cross n or 2 cross p. Now of the options which are given, 2 cross n is given in the question, which is the B option. So we have the answer as B. So I hope all of you were able to understand how to solve some of these important questions of the exercise 3.2. Please do let me know if you still find some of the difficulties. Thank you so much.